Two craters, 16 and 18 meters across, are sitting on the far side of the moon where physics says only one should exist. NASA photographed them 4 years ago, said the rocket must have carried large masses at each end, and then the trail went cold because the country that owns that rocket insists it never crashed. In 4 days, another rocket hits the moon in full view of Earth's telescopes, and this one settles the case. By the end of this video, you'll know what that impact can prove, and what nobody is saying about it. On March 4th, 2022, at roughly 25 minutes past noon Universal Time, a dead rocket stage slammed into the far side of the moon near a crater called Hertzsprung. It was the first human-made lunar impact ever predicted in advance. Astronomers had seen it coming for weeks and published the time and place ahead of the collision. And yet, not a single telescope on Earth could watch it happen. The far side of the moon is permanently turned away from us, and no observatory anywhere had a line of sight. Humanity's first called shot against the moon was scored in total blindness. The collision was calculated, the time was known, and the event itself was witnessed by no one and nothing. 3 months later, NASA's Lunar Reconnaissance Orbiter located the crash site and photographed it. And what came back in those images is the reason this story is still open more than 4 years later. The impact had not left one crater. It had left two. A pair of overlapping pits, one about 16 meters across and one about 18, spanning close to 30 meters end to end. NASA's own public statement said the double crater was unexpected and that it might indicate the rocket body had large masses at each end. Read that carefully, because it is a description, not an explanation. A spent rocket stage is one of the most predictable objects you could throw at the moon. It is a hollow tube, empty fuel tanks running most of its length, with a single concentrated mass, the engine, bolted to one end. An object built that way should dig one crater. This one dug two. And in the 4.5 years since those photographs came down, nobody, not NASA, not the tracking community, not the country that most likely built the rocket, has produced an answer that holds up. This week, that changes. In 4 days, on Wednesday morning, another dead rocket stage hits the moon. And this time, everything about the collision is different in exactly the ways that matter. To understand why Wednesday's crash functions as a verdict on a 4-year-old case, you need to know how strange that case actually is, starting with the fact that the rocket that dug those two craters officially belongs to no one. The object was first spotted as an unidentified point of light and catalogued under the temporary name WE0913A. The astronomer who worked out its fate was Bill Gray, a contract orbit computation specialist whose software tracks high-flying debris that no government agency bothers to follow. In January of 2022, Gray announced the object would strike the moon in March and identified it as the second stage of a SpaceX Falcon 9 that had launched a space weather satellite in February of 2015. That first identification made headlines around the world. SpaceX junk on course for the moon, and it held for weeks. Then it fell apart. An engineer's trajectory analysis showed the object's path did not fit that launch at all. Gray reran the orbital history, publicly corrected himself, and landed on a different candidate, the upper stage of China's Chang'e 5T1 mission, launched in October of 2014. That flight was a test run for China's later lunar sample return program. It sent a capsule looping around the moon and back to Earth, and the booster that threw it there was left drifting in the same poorly watched space where dead rockets go to be forgotten. Independent observers went further. A university team measured the object's reflectance spectrum, the fingerprint of the light bouncing off its surface, and found it consistent with the paint and materials of Chinese rocket hardware, not a Falcon 9. China's response was flat denial. The Foreign Ministry stated the Chang'e 5T1 stage had burned up in Earth's atmosphere, a claim that appeared to confuse two different missions, and one that United States Space Command tracking data contradicted. The stage from that 2014 flight never came home. Beijing has never acknowledged the impact. So the situation, stated plainly, is this. An object matched to Chinese hardware by its own paint hit the moon, left a crater formation that requires mass no one can account for, and the most probable owner's official position is that the object did not exist. That denial matters for more than diplomacy. Because no owner has ever claimed the rocket, no authoritative mass breakdown of it has ever been published, investigators trying to explain the double crater have been working without the one document that would settle it, and the physics they are left with points somewhere uncomfortable. Here is the problem in its simplest form. When an object strikes the moon at kilometers per second, the crater it digs is controlled by its mass, speed, angle, and structure. The Chang'e 5T1 stage came in at roughly 2.58 kilometers per second. Slow by cosmic standards, fast by any human one. An impactor like that, hollow along its length with one heavy engine at the end, concentrates its punch at a single point. One heavy end, one crater, with the light tankage adding little more than a smear. Two overlapping craters of nearly equal size tell a different story. They imply the object carried substantial comparable mass at both ends, something dense where the engine sat, and something dense at the opposite end, where a standard stage carries nothing but an empty tank dome and an adapter ring. A tumbling object does not change that arithmetic. However, the stage was rotating when it arrived. The collision happens far too fast for the rotation to smear one mass into two separate holes. Whatever dug the second pit was already there at the far end of that rocket when it hit. NASA said as much in its own statement, and no public manifest, no mission description, no engineering document on the Chang'e 5T1 flight accounts for any such second mass. We even have a baseline to compare against, because this experiment has been run before, deliberately. During the Apollo program, NASA steered the spent third stages of its moon rockets into the lunar surface on purpose, using the crashes to calibrate seismometers the astronauts had left behind. Those stages were broadly comparable in class to the Chinese booster. Long, hollow, one heavy engine. Every single one of them dug a single crater, each more than 35 meters across. 4 deliberate rocket impacts, 4 single craters. Then, one Chinese stage hits the far side and the moon shows us 2. So the anomaly is not subtle, and it is not a matter of interpretation. It is a photographed contradiction between what hit the moon and what the object was supposed to be, which raises the obvious question, what are the possible explanations, and why has none of them closed the case? There are 3 families of explanation, and each one has a hole in it. The first is undisclosed hardware, an instrument package, a structural adapter, ballast, or some other mass mounted opposite the engine and simply never made public. This is the explanation NASA's wording gestures toward, and nothing rules it out. But nothing confirms it either, because the owner denies the object exists. If there was extra hardware on that stage, the only party who knows what it was has spent 4 years saying the rocket burned up somewhere else. The second family says the stage itself was unusual, that the Chang'e 5T1 booster carried some structural configuration at its forward end, unique to that vehicle, heavy enough to dig its own crater? Possible. But again, no published engineering breakdown, no way to check. The third family is the most unsettling for scientists, because it does not point at the rocket at all. It points at the physics. Maybe a long, tumbling, low-density cylinder coming in at a shallow angle can produce a compound crater under conditions nobody has properly modeled. Maybe the single crater expectation was never as solid as everyone assumed. If that is true, the 2022 mystery is not about China's rocket. It is about every crater calculation planetary science relies on, including the ones planetary defense uses to estimate what an asteroid of a given size would do to the ground it hits. Craters are how we read impact history across the entire solar system, and the reading only works if the translation from impactor to crater is understood. A compound crater from a simple impactor would mean it is not fully understood. And then there's the fourth explanation, the one that circulates online every time the story resurfaces, that the double crater proves the stage carried a secret military payload, and that the silence around it is deliberate. The honest reading of the evidence is narrower than that. The extra mass is real and unexplained, and China's denial does not fit the tracking data. Both of those things are true, but unexplained mass is not evidence of a weapon. An undisclosed adapter or instrument fits the photographs just as well as anything sinister, and the identity correction that started this whole saga happened in public, run by independent observers on open data. The claim goes further than the evidence does. What nobody disputes is that the evidence itself is thin, and it is worth being precise about why. Everything humanity knows about the 2022 impact rests on almost nothing. The far side of the moon blocked every telescope on Earth, so there was no flash measurement, no debris plume observation, no real-time data of any kind. There is the before and there is the after. 2 orbital photographs of a pair of craters, an extrapolated trajectory, and a tumbling light curve measured in the weeks before impact. That is the entire case file for the strangest impact signature in the modern lunar record. No one could rerun the event. No one could image the debris. No agency opened a formal investigation, because no agency is responsible for dead rockets in the space between Earth and the Moon. The collision was called by one contract astronomer, and the follow-up consisted of whatever the orbiter's camera team could photograph on later passes. The case did not close because it was solved. It closed because there was nothing left to examine. Now consider what a watched impact produces instead. A strike on the visible side, timed in advance, means cameras rolling at the moment of contact, debris measured as it rises, spectra taken of the ejecta while it is still in flight, and dozens of independent observers producing data no single agency controls. Everything the 2022 case file lacks, a near-side impact generates by default. That is what makes this week different. For the first time since those 2 craters appeared, The moon is about to be hit again by the same class of object, and this time the experiment runs in full view, with every variable known in advance. On Wednesday morning, August 5th, a derelict SpaceX Falcon 9 second stage strikes the moon's near side, the side we can see. The impact point sits near a crater named Einstein, almost exactly on the moon's western edge as viewed from Earth. Nobody planned this. The stage has been dead hardware for a year and a half, and its collision with the moon is an accident of orbital mechanics, predicted months in advance by the same astronomer who called the 2022 impact. But look at what this accident does for the cold case. The 2022 impactor was an object of disputed identity, unknown configuration, and unpublished mass, striking where no one could watch. Wednesday's impactor is the opposite in every category. Its identity is certain. It is anchored to a January 2025 launch by more than 1,000 tracking observations. Its structure is documented. About 12 meters long, 4 meters wide, hollow aluminum lithium fuel tankage with one Merlin vacuum engine at one end and nothing comparable at the other. Its mass is bounded between roughly 3,900 and 4,900 kilograms, and its arrival speed, 2.43 kilometers per second, is within 6% of the speed the Chinese stage was traveling when it hit. Same class of object, same class of collision. One difference that matters to the physics: this rocket is known, from engine bell to tank dome, to carry its mass at one end only. That makes Wednesday's crash a control experiment. The clean run of the exact test the moon performed in secret 4 years ago. And control experiments are how cold cases actually get solved. When you cannot re-examine the original event, you reproduce its conditions and watch what happens. The prediction this time is specific and falsifiable. A single crater, roughly 17 meters across. In the weeks after impact, the Lunar Reconnaissance Orbiter, the same spacecraft that found the double crater, will photograph the fresh scar near Einstein. That photograph settles the question one way or the other, and there is no third outcome. Before we get to what each verdict would mean, it is worth seeing just how thoroughly this rocket has been watched, because the contrast with 2022 is the whole point. The stage carries the catalog designation 2025-010D. It launched on January 15th, 2025, carrying 2 commercial moon landers at once, Firefly Aerospace's Blue Ghost, which went on to make the first fully successful commercial lunar landing in March of that year, and a second lander that went silent moments before touchdown that June and crashed. The rocket that threw them both toward the moon had no destination of its own. Once its job was done, it was left in an enormous looping orbit around Earth, swinging out past 500,000 kilometers and back, crossing the moon's distance twice on every 26-day lap. For 18 months, the stage and the moon kept missing each other. What finally put them in the same place at the same moment was sunlight, the faint, constant pressure of light itself, nudging a tumbling dead machine, pass after pass, onto a collision course. It has no fuel, no power, no thruster, and no radio. Nothing steered it, and nothing can. The tracking record built around it is extraordinary. By late February, 1,053 observations had accumulated from observatories in Mississippi, Utah, Beijing, and England, alongside asteroid surveys and backyard astronomers. One British observer caught a 12-minute exposure in which the tumbling stage brightened and faded 5 times. Follow-up work pinned its tumble period at just over 3 minutes. Each refinement tightened the impact solution further. A June update shifted the predicted impact point about 170 kilometers. The July 17th update moved it by only a couple of seconds and roughly 10 kilometers. The solution has converged, and it is now one of the most precise appointments in spaceflight history. Compare that to the 2022 case file. A disputed identity, a borrowed trajectory, and 2 photographs. This time, when the crater appears, no one will be able to argue about what made it, and the appointment itself is stamped down to a fraction of a second. The formal solution puts impact at 34 minutes and 32.9 seconds past 6 in the morning, Universal Time, on Wednesday, August 5th. 2:34 in the morning Eastern, 11:34 Tuesday night on the West Coast. The stated uncertainty is about half a second in time and 300 meters in position. The astronomer behind it conservatively trusts a few seconds and a few kilometers. The impact point is 19.455 degrees north, 93.594 degrees west, old, heavily cratered terrain near the crater Einstein, right on the moon's visible edge. The collision arrives at about 31 degrees above the local horizon, moving at roughly 5,400 miles per hour. With up to 4,900 kilograms behind it, that works out to about 14.5 billion joules, the energy of roughly 3 tons of TNT delivered to a single point in a fraction of a second. The blast should excavate on the order of 1,100 tons of lunar rock and soil, throwing it outward into vacuum with nothing to slow a single grain. And out of all of that violence, The number that matters most is the quietest one, 17 meters. That is the predicted diameter of the single crater this stage should leave behind. One clean scar, roughly 17 meters across, is what the physics says a documented one-engine hollow rocket does to the moon at this speed. That number is the test the 2022 mystery has been waiting 4 years for. It also is not a guess. It comes from a body of impact science that started with rockets NASA crashed on purpose. Deliberately hitting the moon with spent rockets is one of the oldest experiments in lunar science. 5 decades ago, Apollo mission planners sent their used third stages into the lunar surface intentionally, so the seismometers astronauts had planted could listen to the shockwaves. The moon famously rang like a bell. Vibrations carried on for close to an hour, and those recordings still anchor models of the lunar interior today. In 2009, NASA did it again with purpose-built precision, steering a spent Centaur stage into a shadowed crater at the lunar South Pole so a trailing spacecraft could fly through the debris and search it for water ice. It found it. The mission confirmed water in the lunar soil, and it did so by reading the contents of a debris plume kicked up by a crashed rocket. Impacts, in other words, are not just accidents on the moon. They are instruments. Every one of those deliberate crashes produced data, because the impactor was known mass, known speed, known angle. That is exactly what makes crater science work, exactly what almost every natural crater lacks. The equations that translate an impact into a crater, the same scaling laws used in planetary defense to estimate what an incoming asteroid would do to a city, are calibrated on a handful of events like these. Wednesday adds one more, for free, at a precision the Apollo era could only dream of. An impactor documented down to its tumble rate, arriving at a time known to the half-second, which brings everything back to the 2 craters near Hertzsprung. The Apollo stages are the baseline that makes 2022 anomalous. 4 known rockets, 4 single craters. Wednesday's stage is the 5th known rocket. Whatever scar it leaves is the deciding data point. In the weeks after impact, the Lunar Reconnaissance Orbiter will pass over the site near Einstein and photograph the fresh crater. There are 2 possible pictures, and each one answers the 4-year-old question differently. Picture 1, a single crater roughly 17 meters across. The physics closes cleanly. Hollow rockets with one heavy end make one hole, confirmed now on the near side in public by an object nobody disputes. But that verdict has a sharp edge, because if the physics works, then the 2022 double crater cannot be explained by impact dynamics. It hardens into evidence that the Chang'e 5 T1 stage physically carried significant undisclosed mass at its far end, hardware no document describes and no government will discuss, on a mission whose owner still denies the impact happened. It would not tell us what that mass was. It would tell us, with a confidence the story has never had before, that the mass was real, and that the only remaining explanations sit with a government that has spent 4 years refusing to engage the question. Picture 2, anything other than a single clean crater. If Wednesday's fully documented single-engine stage also produces a compound scar, then the assumption underneath the whole mystery collapses. It would mean tumbling. Hollow rocket bodies can strike the moon in ways our crater models do not capture. And the 2022 anomaly dissolves from a question about China's rocket into a question about everyone's physics, with consequences for how we read every crater on every world. One photograph, either an unexplained payload on a denied rocket or a hole in impact science itself. That is the verdict, and it is finally coming. And unlike last time, the strike itself happens where all of us can try to watch it. The impact site sits nearly on the moon's western limb, and that geometry is the viewing opportunity. The flash itself is a lost cause. The site is in full lunar daylight, and no impact flash has ever been convincingly seen against the sunlit surface. The prize is the debris. Dust thrown upward from the limb could climb into black sky above the moon's edge, lit by the sun against darkness. How high it climbs is a genuine open question. Modeling published this July projects an ejecta curtain rising 15 to 20 kilometers, with a fast central spike reaching 75 to 100 kilometers. While the astronomer who predicted the impact cautions the debris may rise only about 3 kilometers and hug the glare. If the models are right, backyard telescopes across 2 continents see it. If the caution is right, almost nobody does. Eastern North America and South America have the best geometry, with the moon about 56% lit in a dark sky at impact time, rising around midnight to 1 in the morning, local time in the eastern United States, with Saturn nearby in the sky as a convenient signpost. Anyone planning to record it can rehearse the night before. On Tuesday night, the moon sits at nearly the same phase and position, a full dress rehearsal for the real thing 24 hours later. Observers are being pointed at one more measurement worth knowing about. The stage's tanks are an aluminum-lithium alloy, and a filter tuned to lithium's emission line at 670.8 nanometers could catch the chemical fingerprint of the rocket in its own debris cloud, a first in history, and a proof of concept for reading what an impactor was made of from the light of its ejecta. So here is the timeline to hold on to. The final tracking updates land over the next few days. Watch for a last refinement of the impact point, because a shift of a few kilometers the wrong way could slide the site over the limb and out of view. The impact itself comes Wednesday morning at 2:34 Eastern. The plume question gets answered within minutes, and the verdict, the photograph that either exposes an undisclosed payload on a rocket, Beijing says never crashed, or breaks open the crater, physics planetary science depends on, arrives in the weeks after, when the orbiter's images come down. We will be tracking the final solutions, the impact window and that photograph as it lands. 4 years of silence around two overlapping craters ends this week,